All right, so Jared has an average of 86, and then he's going to his final exam. He doesn't really want an A, but he wants at least a B plus.
Why?
Why is a good question, but we'll find out. So, there are 55, the final exam is 20% of the final grade, and there are 55 points on the final exam. How many points does he need to get to that 88%? So the first thing we've got to understand is 20% is 1/5 of your final grade, right?
Yep.
So that means that this part here makes up 4/5 of his final grade, right? So that means that if we break this into fifths, we have his 86, and that's 4/5, right?
Yeah.
Plus whatever he gets on his final exam, right? That would be his percentage on the final exam. And we divide this all by 5, because here's his current grade, here's his final exam right here. Divide that by 5 to get his average, and he wants 88. Feeling good so far about this?
Yep.
Yes.
Okay, so now we just have a little bit of train tracks. So divide both sides by 5, and we get 86 times 4 plus x is equal to, and I think that's 440, right? So 86 times 4 is? 344 plus x has to equal 440. All right, so what is the percentage he has to get? Well, so he has to get a 96 on the exam. But wait a second, the exam is made up of 55 points. Okay, so if this is his percentage, that means the number of points he needs to get is 55 times 0.96. So 5 times 6 is 30. Carry the 3. 5 times 9 is 45. Plus 3 is 48. Carry the 0. So then 5 times 9. 5 times 9 is 45 again. Carry the 4.
You're supposed to do 6 times 5 twice instead of, I think you did 6 times 5 and 9 times 5.
Oh, I think you're right. I think you're right.
I got them.
That's why I keep you guys around. All right. So 5 times 6 is 30. Carry the 3. 5 times 9 is 45. Plus 3 is still 45, right?
Wait, no, it's
No,
5 times
6
6
times
and 5
5.
times 6.
33.
You do 6 times 5.
6 times 5, 6 times
Again.
5, 2 times.
Oh, so what I'm doing, I'm doing it backwards.
Oh.
Ew.
So I'm 5 times 6, 5 times 9 is 45 or 40.
Yeah, but then
So-
the other way you did 9 times 5.
So then I'm doing it backwards here. 5 times 6. So add the 0. 5 times 6 is
30.
30. Carry the 3. 5 times 9 is 45, right?
Yeah.
So we get the 48 again, right? And so then we add straight down, and we get 8. We get a 0. We get a 2. And we get a 5. There are 2 decimal places here, so 2 decimal places here. So can you get 42.8 questions
No.
right? No, there's no partial credit, so that's how we get 53 points.
Yeah.
Okay. All right. He could have just got 100 on the test, but something tells me even 100 is not going to get him to an A. All right. Yeah, this one is fairly quick. So we have 100 students total.
Yep.
And in that 100 students, we have 90 who study English, 75 Spanish, and 42 study French. Every student must have at least one language, so no one can opt out of language.
Why would you study 3?
I don't know, but someone wants to.
They want to be
There's several. Actually, what we really want to know is how many people do want to study all 3 languages. So this is one of those Venn diagram problems where we have English, French, and Spanish. Now here's the thing. Here's where the time suck could really happen. Do we really want to know how many people are in each section of these things?
Yes.
No. We only want to know this section right here.
The special section.
This one right here. So, here's what we want to do. We are going to assume that nobody is taking just one language, because we want to find the least number possible right here. If a bunch of kids take one language, then that means more people have to be tripling. Does that rationally make sense? Okay.
Yeah.
So we can fairly assume for this problem, these sections are all zeros.
What?
Okay.
Because this means you're only taking English, only taking French, only taking Spanish. So then, okay. So if I have 90 students taking English, and 75 taking Spanish, and 42 taking French, that's a total of 207 seats that are being occupied in language classrooms. So we already know that no one is taking just one language in this problem. Which means if every one of these 100 students take 2 languages, how many seats are taken? 200. Well, how many people would then have to be taking 3 languages? 7.
That's a lot easier.
Oh, wow, that's
I wish I knew.
So that's what I mean. This one's a much faster problem than it appears because it's so tempting once you draw this Venn diagram to try to figure out each section. But if you do that, you're going to be taking a long time.
And
So-
I did not get the correct answer to the one.
Right. And doing the long way. Now this one I'm guessing was a struggle as well.
I got it.
You got it? That's awesome.
I don't remember how I did it, but I got it.
So,
I got 8/3.
I got 8.
I got 8 fifths.
Oh wait, that's I did.
So-
I got 8/3.
Oh wait, no, I
so
got
here we go. Here we go. So for this one, so I was working backwards. So for this one, this is kind of a classic algebra problem, a mixture problem. Do I expect you to write this down while we're working on it?
Yeah.
Yeah, kind of. All right, but there's an added trick. Normally, in these mixture type problems, we're just adding, but in this case, we're draining and adding. So we have a 16-gallon tank that is 40% antifreeze, which means that it is 60% water. And we're going to drain that tank a little bit and put in pure antifreeze so we have a higher percentage of antifreeze. Does that make sense so far? Okay. So if we have 16 gallons, the first thing we need to know is how much actual antifreeze we have in the tank right now. So if we have 16 quarts of mixture, and it's 40% antifreeze, how much is remaining? So I'm sorry. So hold on a second. 6.4. Why did I hear 1.6? I'll tell you why I heard 1.6 because that number comes up later. So that's 6.4. So that's 6.4 quarts of antifreeze, right? Okay. But if we want to get to 50% antifreeze in a 16-quart capacity tank,
You have to add 1.6. Or it
Yeah.
need 1.6.
right. So because we need to get to 8, right? Because half of 16 is 8. So that means we need to add 1.6 quarts of antifreeze. But wait a second.
We're also draining.
We're also draining it. So when we drain the tank, we're not just draining water, we're also draining antifreeze, right? So if I put in 1 quart of antifreeze, how much more antifreeze am I adding? Well, right now this is 40% antifreeze, which means that for each quart that I'm adding, I'm actually adding 0.6 quarts of antifreeze because I'm removing 0.4 quarts of antifreeze along with 0.6. So really the net gain is only 0.6, not 1. Does that make sense? Okay, well, so if I need 1.6 quarts and I'm adding in increments of 0.6, what do I have to do with 1.6 and 0.6? Divide. 1.6 divided by 0.6. Well, I'm just going to multiply both of them by 10.
16 over 6.
Which then reduces to 8 over 3.
Yeah.
Ta-da! Would I be able to do these problems in competition? Maybe. Maybe not. We'll see. All right. But that's kind of a cool problem.
Yeah, it is.
I like that.
I've seen these before. and it's just don't-
All right. So we'll do two more. We'll do two more and then we'll move on. All right. So here's the thing. The smallest integer greater than 2 that will have a remainder of 2 when divided by any member of the set. So what we really need to find is we really need to find the least common multiple of these numbers. And then once we do that, if we add 2, then we found our number. So if a number is divisible by 8, what else is it divisible by?
4.
Okay, so I'm not going to worry about that. Because if it's divisible by 8, it's also divisible by 4.
If it's divisible by 6, it's also divisible by 3.
If it's, okay, so I don't need to worry about the 3. But wait a second. So this has a 3 in it too, right? Alright.
That too.
0.
But we already we already have the 2 taken care of in the 8, right?
Yeah.
So what is 3 times 5 times 8?
120?
That's 120. Well, we want to have a remainder of 2, so what's our magic number? Add 2 to get 122. So that one is kind of gettable.
Yes.
Alright, so the last one that we're going to look at, the sum of 3 consecutive terms in an arithmetic sequence
What's an
is,
arithmetic sequence?
I'll explain in a second, is 27. And the sum of their squares is 293. What is the absolute difference, so no negative answers, between the greatest and the least of these numbers? An arithmetic sequence is linear. When you see arithmetic, you should think, yeah, linear. So that means it's really easy for us to find a middle term. So if we have 3 numbers and their sum is 27, what's the middle term?
The average of the 2?
It's the average of the 3, which is 9. Now the trick is we need to find these numbers here.
9 plus 11 plus 7.
Now there's a trick that helps us here. We know their squares, the sum of their squares is 293. We know what the square of 9 is, 81. So that means the difference here, if I subtract out my 81, we get 2, right numbers, wrong order. So we get 212. So, well, let's start subtracting out some numbers less than squares that are less than 9 and see if we get a square number, right? Alright, so if we subtract out 64, that's going to get us 8. Well, can anyone think of a square number that ends with 8? No.
No, it has to be a cube
Alright, so 64 doesn't work, so 8 doesn't work. What about 7? 9, right? So 7 squared is 9. That, 1?
One could,
Then
that
it has
means
to
you
be
need a,
9 though.
has to end with 1 now.
You can only get
170, no.
No, yeah, that doesn't, that doesn't work
It
so
has to
well.
be 9 or 1.
Yeah.
1 would
Okay.
work.
So then 7, 6 would be 36. We get 6 here.
Could be 6.
We get 7. Oh, that's not going to be okay. Does that work?
No.
No. Alright. So then 5. Is 5 going to work with the. That would give us a 7 at the last?
No.
4. Should we just submit our thing with the answers we already have?
Yeah. Yep, that's exactly right. Alright, so 5 is clearly not going to work. What about 4? 4 squared is 16.
96,
And what do you get?
14 squared.
14 squared? No way.
196.
You get 196?
No.
I don't
19
even know that.
196. Okay, so that means 4 and 14. Oh, well, that's not too bad. Now we just find the difference between the largest and the smallest. So it's 10.
I actually think.
That was way easier. I didn't even answer the question.
Yeah.
So there you go.
Everything.
So those are the last 5 in that competition. Some of them a little easier to get than the others. That last problem, quite frankly, at the end of the competition, with all that arithmetic, would be kind of tough to get done in time.
I thought like arithmetic sequence is like in a row, so I got 9 and 11 and